Okay, problems 18 and 19 are very similar, so I'm just going to work one of them. So let's just do the first one here. Number 18. So it says that my function f of x is equal to 2 times x minus 2 squared minus 2. So when it comes in vertex form, and both 18 and 19 are in vertex form. You know, the vertex form says that a times x minus h squared plus k is equal to y. So in vertex form, we can see the h and the k. We know hk is the vertex, okay? So what I always remind people is that h, whatever you see here, he's lying. And k, he's telling the truth. So in other words, it looks like a -2, a -2, comma, -2, but really it's going to be a +2, -2. Okay? So that's going to be my vertex. Now, next it asks me for, so let's go ahead and put that in here. So it's going to be 2, comma 2. 2, comma, -2. Now, next it asks me for my y-intercept. I know my y-intercept is where my line crosses, or my curve in this case, crosses my y-axis. So everywhere on the y-axis, x is equal to 0. So this is the key to the problem, that at the y-intercept, x is equal to 0. And at the x-intercept, y is equal to 0. Okay, so let's see. At the y-intercept, x is equal to 0. So we're just going to replace everywhere there's an x with a 0. And that would be 2 times 4 is 8, minus 2 is 6. Okay, so when you enter it into your iMathAS, you need to enter it as an ordered pair. So if x is 0, y is 6. So my y-intercept will always have a number in the y and a 0 in the x coordinate. Now, for my x-intercept, y is equal to 0. So I'm going to replace my y with 0. You may say to yourself, wait, there is no y. That's why you have to remember that f of x is a fancy way of writing y. So we're going to replace it with 0. And now we're going to solve the quadratic. That's what we keep doing in this section over and over. So you can use the quadratic formula. You can use your calculator if it's a real number. And I'm going to use the square root property because I can easily isolate the square. So I divide both sides by 2, and I get 1 is equal to x minus 2 squared. Once I've isolated my square, I take the square root of both sides. And whatever number I'm taking the square root of, it's going to be plus or minus that. It's going to be 1. Okay? Now I'm going to add 2 to both sides. And I'm going to get x is equal to 2 plus 1, or x is equal to 2 minus 1. I've got 2 different answers. So it's going to be 3 and 1, right? So when I put it in as ordered pairs, I'm going to say 3, comma 0 and 1, comma 0. Okay? I want to make a comment on here because this could be, this one here, you can easily see this would be when y is 0, x is 3. So make sure that you put the x in the x position, and y will always be equal to 0 for the x-intercept. Okay? But also on this problem, it tells you that if necessary, you may round to 2 decimal places. So I just want to show you something else. I did this problem a few minutes ago with a different set of numbers, and I got a radical for my answer. So I want to point out what would happen. So assuming you got a different problem, because everyone's are different, let's assume that your answers turn out to be 3 plus or minus the square root of 2/3. Okay? Now you may think to yourself, oh, I'll just put this into my iMath AS like this. Right? You may think, oh, that'll be fine. I can put it in, that's exact, but it will mark it wrong because it wants to be able to graph it, and we can't graph radicals. So if you get something like this, if you get one of these ones that ends up with a radical as your answer, put it into your calculator, okay? And find out what this is as a decimal, and then enter that in. That's why it says over here, if necessary, you may round to 2 decimal places. When we graph, we can't graph things that have radicals. So I just wanted to point that out, that if you get one that has a radical as part of your answers, do not try to enter it in as part of your ordered pair. Instead, use your calculator and round to 2 decimal places. That wasn't mine, but I just noticed it earlier to another problem when I was practicing, and I thought, that could get you. So be careful of that. So now let's graph it. Okay? So we come into our graph, and we have to choose the correct one. Now, we're always going to choose this button. So for our class, we're only going to graph parabolas that open downward or open upward. So you're going to always choose this button. Do not choose the parabola on the side. We're not going to do that, okay? Now, you choose that button, and then I'm going to enter my vertex. My vertex was 2, -2, and my y-intercept was 0, 6. Problem number 19 is the same problem with just different function. So for problem number 19, let's just talk it out since we're here anyways. So every answer is different. Your ordered pair here would be 1, -2 for your vertex. H lies, K tells the truth. We know it's going to be going down because of -3, so it'll be opening downward. My y-intercept, I put an x is equal to 0. Let's just go ahead and do it. What the heck? So that would be -3 times 1, be -3, it'd be -5. Okay, so when x is 0, y is -5. So that would be my y-intercept. Just a reminder that you want to put it in as an ordered pair. Okay, and then my last part is state the x-intercept of the graph. So this time I'm going to set it equal to 0. My y is going to be equal to 0. I'm going to solve for x. So I'm going to add 2 to both sides. And I'm going to divide by -3. And then I'm going to take the square root of both sides. So I can see that I'm going to get as my answer x is equal to 1 plus or minus the square root of -2/3. Okay? So if I wanted to enter this in as a decimal, I'm going to have problems now because I've got an imaginary number, don't I? So if there is an imaginary number, it means that I'm going to say there is no real answer. So since this is imaginary, and we know that because it has a negative underneath the square root, I'm going to say that there are no real solutions, okay? There are no real x-intercepts. So I'm going to type in DNE, okay? Now, why is that? Let's think about this for a second here. Make some room for discussion here. So I know by looking at A whether my parabola opens up or downward, okay? So if I were to graph my vertex at 1, -2, 1, -2, down here, okay? And then if I looked at my function, let me draw it. So 1, -2. And if I looked at my function, I said that A is -3. And I said when A is negative, my parabola is like a negative person. It opens downward. Well, would I ever have an x-intercept? Nope, it would never cross the x-axis. That's why there are no real x-intercepts. There are no real x-intercepts. They're imaginary. So that's why I'm going to put DNE. And it tells me in the directions, if there is no real answer, input D and E. So there are no x-intercepts, no real ones. So we put that. So how do I graph it then? Well, then I'm just going to use my vertex and one of those intercepts. So I'm going to do 1, -2, 1, -2, and then I can't see my other one. Let me see if I can see up here. My 0, -5 was my y-intercept. So 0. Oh, I should have used my parabola tool. So 1, -2, and then 0, -5. And that anchors my parabola. Let's just check it, make sure we're right. And I didn't make a careless mistake, and that's exactly what it looks like. Okay, so that's what you do when you have no real x-intercepts. Okay. Number 20. This one is in standard form, so it's going to be a little different. We already know how to find the vertex, so we already talked about that in an earlier problem. So hopefully this part is pretty much review. So if I want the vertex of this function, I'm going to say h is equal to -b over 2a. Make my little template before I do anything. In our case, b is 5 and a is -1. Okay, so I have -x squared, so it's -1, and then plus 5x, so it's plus 5 is going to be my b. Okay, so I have -5 over -2, which is 5 over 2. Or we could say 2.5 if you like decimals, your choice. So k is going to be when you just plug in 5/2 into your original equation. Now notice I put parentheses around every variable. This way you don't screw it up. Trust me in this one. Okay, so this would become, I'll just use my calculator if I can find it. Okay, so I'm going to put negative, and then I put parentheses to follow exactly what I see on my paper. Squared. Okay, plus 5 times 5/2. Oops. Minus 6. And then I hit enter. And it tells me that this is going to be 0.25. Now, if I want it as a decimal, if I want it as a fraction, I just hit math 1. And that would say 1/4. Okay. All right, so I could enter it that way, or I could just say that it's going to be either 5/2 and then 1/4, but it wants decimal, so I'm going to say 2.5, 0.25. That is going to be my vertex. Okay. Now it asks me for my y-intercept. You know what? My y-intercept, x is equal to 0. You have to know that. That's the key. So that means I'm just going to take everywhere there's an x, I'm going to replace it with 0. And notice I put a parentheses around every x, and then I just put a 0 there. So I'm going to get -6. So my x-intercept will be 0, my y-intercept will be 0, -6. Okay, so let's go ahead and type these in. So my vertex, I said, was 2.5, 0.25, and then my y-intercept is going to be 0, -6. Okay, let's find the x-intercept now. We know at the x-intercept, y is equal to 0. So we're going to set our function equal to 0. And it's a quadratic, so we're going to either use quadratic formula. You could try to factor it. You can't use the square root property because there's a bx in the middle here. But I think I'm going to try to factor it. So I'm going to take out a -1. And I want to factor this. So I want to find a factor pair that adds to be 3, and then, that multiplies to be 6. I don't know how I got a 3 there. Sorry, 6. All right, so I want to have a factor pair that multiplies to be 6 and adds to be -5. So how about, let's see, -3 and -2. So that would be -3x and then plus negative 2x, that would be right. Okay, so x minus 3 is equal to 0, and x minus 2 is equal to 0. So I'm going to get x is equal to 3, and x is equal to 2. But I want to enter them in as intercepts as ordered pairs. So I'm going to say 3, 0, 2, 0. Okay? Remember, the intercepts we're going to always enter in as numbers. And we're going to put the number in the x position. And then this will always be 0 for the x-intercept. Okay? And if you end up with a radical, make sure you put it in your calculator and then round it to 2 decimal places so you could graph it. So now let's see what this looks like. So if I graph 2.5.25, and let me just clear this to show you. I'm going to hit this button to clear. And if I want to graph that, I notice that, unfortunately, they're not the best increments for us, intervals of these. So 2.5 is halfway between 2 and 3. So I don't want to press it, but I want to know I'm in there. And then if this is 2, then halfway would be 1, and a quarter of the way would be 0.5. So I think I'm really close, like right around there. And then my y-intercept is negative 6, which is off my picture here. Let me scroll down a little bit. So I'm going to go down here to there, and that will be my graph. Okay? Let's look at the next one. I think we're getting to the end here. 21. A stone is thrown vertically upwards from a platform that is 19 feet above ground at a rate of 115 feet per second. That is all just lovely information we have to put into this equation. So it says using the projectile formula. So when you take physics, they teach you this. We're giving it to you, okay? So they're saying that the projectile formula is h is equal to negative 16 t squared plus initial velocity plus times t plus initial height. To find out how long it will take the stone to reach its maximum height, and then find the maximum height the stone reaches. Okay? Recall that the initial velocity is v sub 0 and h sub 0 is the initial height. So let's take our formula. Okay? And let's replace the initial velocity, v sub 0, with 115 feet per second, because that's the rate they told us. So in place of v sub 0, I'm going to put 115. And then in place of h sub 0, which is the height, I'm going to put 19. Those were given in my my word problem. So it told me that 19 feet above ground, that's my height, and 115 feet per second, that is my initial velocity. Okay, so now I'm just going to have to solve this. It says it wants me to find the maximum height. Whenever I see the word maximum or minimum, I know that is my velocity, that is my vertex. Okay, so since I'm in standard form, I know that my x coordinate will be negative b over 2a. Okay, this is my x coordinate of my vertex. I know it because I have to memorize it. Okay, so b in this case is 115. It's negative. And then 2a is negative 16. So I end up with 115 divided by 2 times 16, which is 32. To get my y coordinate at my vertex, I just put that in to my equation. So it's going to be negative 16 times 115 over 32 squared plus 115 times 115 over 32 plus 19. So wherever you had an input, you're going to put that in. Let's just go ahead and put that in the calculator. So negative 16 times 115 divided by 32 squared plus 115 times 115 divided by 32 plus 19. Okay, and if I want that as a fraction, I say math 1, and it gives it to me as a fraction. My input is time, and my output is height, right? So my vertex will be this 115 divided by 32, and then 14, 40, 41 divided by 61. So let's see what that is. Let's see, we already had that. So 14, 4, 41 was 225.64. So let me just put that in here. So that's going to be 225.64. Okay, and then the other one was 115 divided by 32. Let's see, I think we already did that one too. Let's go up a little back there. Is 3.59. Okay, so that is my vertex in decimals. And the reason I rounded it to 2 decimal places is because it said on my note, round any numerical responses to 2 decimal places. Okay, so that is my maximum height there, your units. So this is seconds, and this is feet. And the reason I know that is because my rate was 115 feet per second. Okay, so that means at 3.59 seconds, it's going to be 225.64 feet. So I'm going to say it reaches its maximum height after, and there's 2 afters there, I'll have to tell them to fix that, 3.59 seconds. Oh, and we don't want to type the units there. Instead, we're going to pick it here. So just be careful. And then I'm going to say 225.64. And once again, I'm going to pick the units. At least get those units right. There we go. And that's going to be the answer. So this is really an application to make sure you understand that the vertex, it gives you 2 things. It gives you the input and the output at the maximum. And in our case, the input is time and the output is height. All right, let's try the next one. Problem 22. A family with 3 young children just moved into a house with a yard that is not fenced in. The previous owner gave them 252 feet of fencing to enclose part of their backyard. The quadratic function they're giving to us. So it says the area is equal to x times 252 minus 2x. And it gives the area when x is the width used. Find the width that gives the maximum area, and then find the maximum area that can be enclosed. Okay, so when you hear the word maximum or minimum, I want you to think vertex. Very important in this class. Maximum or minimum, ding, 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 vertex. So how do I find the vertex of this? Well, first of all, is it a quadratic? Well, it is, because if I were to multiply this out, this would be 252x minus 2x squared. Right? So it is a quadratic. So how do I figure out the vertex? Well, I'm going to rearrange it so it's nice and neat. Okay. And to get the vertex, I'm going to say negative b over 2a. So I'm going to say negative 252 over 2 times negative 2. I'm going to use my calculator. Negative 252 divided by negative 4. 63. Okay. And to get my k, I'm just going to input 63 into my original equation. So I can do it this way even. 63. And then times 252 minus 2 times 63. I could put it in either equation. I could put it in this beginning one or the next one. It doesn't really matter. It's the same answer. Okay, so what does that mean? Well, that means that if I have input of x, I get an output of area. Okay, so that means that if my input is 63, my output is 7938. That's my vertex. Okay, so what does that mean? That means it'll give me a maximum area. The width that will give me that will be 63. And the width will be feet. Be careful on these. And then the maximum area will be 7938. And area is always in square feet. So the width that will give the maximum area is 63 feet, and the maximum area is 7,938 feet.